Hello and welcome, and thank you for watching this next video in my geometry series titled Equations of Lines and Slope-Intercept Form. In this video, I plan to go over examples on how to write the equation of a line using the point and a slope of a line and writing into the slope-intercept form. Now let's review first of all what the slope-intercept form is. The slope-intercept form of the equation of a line is the equation y is equal to mx plus b, where m stands for the slope of the line and b represents the y-intercept when our line is going to cross the y-axis. Now, in order for you to be able to write the equation in this format, you need to identify again the following those two things: the slope simply and the y-intercept. And there's several ways that you could be given the scenario. You could be given one, the slope and the y-intercept. So you just simply plug in those numbers in the corresponding places. You can be given the slope and a point on the line, or a solution to the equation, which is essentially a point on the line in x and y coordinates. And the third scenario is that you're given again simply 2 points on the line. There's also a fourth, you actually are given the graph. You could be given a graph, but we're not going to look at examples of that. We're going to focus only on these three scenarios. So let's look at the first example. First example is when we're given again the y-intercept and the slope of the line. Since in our formula of y is equal to mx plus b, m stands for the slope of the line, we're told that m is equal to, the slope is equal to -3. So m is equal to -3. The y-intercept is 2. So for the b value, we're going to plug in 2. And thus, we end up with this equation. So that would be the equation of our line. Y would equal to -3x plus 2. On our second example, we're going to go over how to write the equation of a line when we're given again the second scenario of a slope and a point. Well, since we have the equation y is equal to mx plus b, we already know that the value of m is going to be the number 4. Because again, it's given to us. We're told that the slope is 4. The only thing that we do not know is what the value of b is. So I'm going to use this equation, or this equation right here, y is equal to mx plus b, to solve this equation for the y-intercept, for this value of b. So knowing that our slope is the number 4, I can pick and plug in a number for x and for y because that's what's provided for us. We're providing an x and a y coordinate. So if I plug in those numbers in the corresponding places, I get that 5 is equal to 4 times -2 plus b. Multiplying 4 and -2, that's equal to -8. And then adding, or essentially moving the 8 to the other side with the 5, I get +8. So I get that the value of b is equal to 13. So there, I now know what number to plug in for the letter b. For the letter b, I'm going to plug in that number of 13. So that's how I figure out what the slope-intercept form is. Y would equal to 4x plus 13. Now, normally I tell my students to do this. I usually have my students write this formula backwards. It's just simply y equals mx plus b, but we write it in the opposite order. I write b plus mx is equal to y. For some reason, they like writing a formula like this and doing the exact same thing and plugging in again the numbers in the corresponding places. I get that b minus 8, because that's going to equal to a -8. So -8 is equal to 5. And they like this because they're usually more comfortable writing the equation in this format with the variables in the very front. And then simply adding the 8 to both sides. Again, they get that the value of b is equal to 13. So in the next examples that we do that, when we're looking for the y-intercept, I'm going to be writing this exact same equation, just simply in this order, backwards. Notice again that's written backwards. B plus mx is equal to y. So like on this example right here, again, we already know that the slope of the line is equal to, again, we're provided that the slope of the line is equal to that. We just now need to identify what the y-intercept is. So using the formula y is equal to mx plus b, I'm just going to simply write it backwards. B plus mx is equal to y. And I'm going to plug in again the numbers that I provided. I'm provided that m is the number 1/5. The x I'm going to get from the ordered pair, which is 3. and that's going to equal to the y value, which again is provided to me from the ordered pair, which is -2. Multiplying 1/5 and 3, that's equal to 3/5. And here I would subtract, moving this, I would subtract the 3/5 from the -2. So let me put that over here. So I have -2 minus 3/5, which is equivalent to -2/1 minus 3/5. I need a common denominator. I need both of these numbers to be the same value. So I need these two numbers to be the same. So I'm going to multiply this fraction by 5/5. So I'm going to multiply the top number by 5 and the bottom number by 5. And there, now as a result, now with the denominators being the same, I can actually now subtract the top numbers. So I can subtract -10 minus a +3, and that's going to equal to -13. So -13/5. So that's the value of b. b is equal to -13/5. So this is equal to that. So here's our equation. Y is going to equal to the slope of 1/5 times the value of x plus -13/5. And adding a -13/5 is the equivalency of just simply subtracting 13/5. So I'm going to write the answer like that. On our next example, this is the scenario when we're given 2 points. So this one's going to require, again, first two things. The first thing is that we're going to have to use the slope formula, the change in y over the change in x, which is y2 minus y1 over x2 minus x1, and then use y equals mx plus b, which I am simply writing backwards to figure out what the value of b is. So let's start with the first equation, or the first formula, this formula right here. So y2 minus y1, that would be -3 minus +3 over 2 minus 4. Again, x1, y1, x2, y2. And let me make this one look more like a y. So now, subtracting -3 minus 3, that's equal to -6. 2 minus -4, that's equal to -2. And then we'll dividing both of these by -2. They have a common factor of -2. Or simply dividing them, I end up with +3. So we end up with +3. So the m value is equal to 3. So that's going to be our m. Now to figure out the b value, again in this formula, y is equal to mx plus b, I am going to get, again, y equals mx plus b, just simply writing it backwards. Okay, I'm just getting this formula here and writing it backwards, as you see right there, and plugging in the corresponding values. So I do not know what the value of b is. That's what I'm looking for. I just calculated that the m value, again, this m value is equal to 3. So I'm plugging in 3 right there. The x value I'm going to get again from our points, and we have 2 to choose from this time. I could either use the first set or I'm going to use the second set. I'm going to decide to use the first set. So the number I'm going to use for the x is going to be 4. And that's going to equal to the y value, which again, I'm going to use that number right there, which is equal to 3. And again, since I use the 4 for the x, I have to use the 3 for the y. I cannot use the second set if I use the first set. So I cannot be interchanging those values and use 4 and then -2. Or -3, or use the +2 for the x and then this +3 for the y. All right, I have to use again the same 2 numbers in the parentheses. And then from there we solve. So we have b multiplying these 2 numbers is 12. That's going to equal to 3. And again, subtracting the 12, moving it to the other side basically, we get that b is equal to -9. So there we have our two values. We have now calculated that the value of m is equal to 3, and that the value of the y-intercept is equal to -9. So -9. So substituting in those numbers, we get this equation right there. Now, on the next example, we are provided again a slope. They just don't straight out say like in examples 3 or example 2. But in example 5, they say it indirectly. They're telling us that we want to find the equation of a line that is parallel to y equals mx 2x minus 3 and passes through the point of -1 and 1. So they want us again to write the equation of y equals to mx plus b. But they're already providing us the slope. They're telling us that they want this new line, again, this new equation right here, to be parallel to this line there. Well, in order to be parallel, the slopes of the two lines have to be the same. So this slope here has to be the exact same slope as that line right there. So this number and this number right there have to be the same number. So as a result, the value that we're going to use for m is going to be +2. So that's the number I'm going to use right there. Now the y-intercept is not going to be the same as this one right here, okay? So that we're not going to use the same number. From this equation, the only thing that we need is the slope, because we again need it to be parallel. So the way we're going to figure out the y-intercept for this new equation is again using this formula right there, plugging in our slope and plugging in the x and y values. We can then figure out b. So I'm going to write again this formula, y equals mx plus b, just simply backwards. So b plus mx is equal to y. I'm going to plug in the number 2 for our slope. I'm going to plug in the number -1 for the x, and plug in the value of 1 for the y, because this is going to be the x and the y values that we plug in here and there. Let me just fix this. That should be a plus sign. And multiplying 2 with -1, that's -2. And then moving the 2 over, that's going to make it +2. And b is going to equal to 3. So this is going to be the equation of our new line. Y is going to equal to 2x plus 3. And again, this y-intercept had nothing to do with that number right there. There's no correlation at all. It's not helpful. It's not the opposite. Okay, just a coincidence that it happened to be the opposite. But again, I cannot stress that enough, that from the equation, the only number that we needed was that number right there. So these two lines, if I was to graph these two lines would be parallel to each other, which is what I'm looking for. I was looking for this new line to be parallel to this line, and it goes through that point right there. So this equation satisfies the condition of being parallel and going through the point -1, +1. And again, we can check that the parallel, we can check because they have the same slope. And we can check this right here by plugging in -1 in for x and seeing that the y value is equal to +1. So let me do that. Let me show you how to check. So if I plug in -1, substitute in x with -1, and I add 3, this is equal to -2, I'm sorry. And adding -2 with 3 is equal to +1. So equals +1. So y equals +1, which is again what we have right here. So when x is equal to -1, that's that number there. I get that y is equal to 1, which is exactly what I get there. So you see, this line has this point, goes through that point there. And for our last example, it just wants us now, again, similar situation. We just want to now to identify a line, the equation of a line, y equals to mx plus b, where this new line here is going to be perpendicular to the current line, to this current line right there. So again, first of all, the y-intercept is going to be irrelevant. That's not going to be helpful. But in order for two lines to be perpendicular, this slope have to be opposite reciprocals. So the slope of one line, I use M1 to represent that, has to be the opposite reciprocal, so meaning it has to be flipped for the second line. So if this line has a slope, let me highlight that. If this line has a slope of -1/2, to do this, to get the opposite and reciprocal of it, to flip it like that, the new slope that I'm going to use, the slope I'm going to use here for this m right there, has to be the opposite of -1/4, which is positive, and it has to be the reciprocal of 1/4, which is 4/1. So this is the number I'm going to use for this m. And then to figure out the y-intercept, well, I simply do the exact same thing I've done on the other examples. I simply get again this formula, write it backwards. B plus mx is equal to y, and I substitute in the following numbers. For m, I'm going to substitute in +4. Again, this new slope, not the one from the line, but the new one I'm going to plug in here. The x value, again, I'm going to get from the ordered pair, which is the 4, and I'm going to equal it to the y value, which is 2. So multiplying 4 and 4, that's 16. Moving the 16 to the other side of the equation makes it -16 because I'm adding. So b would equal to -14. So there you have your two values. Your value of b is equal to -14, and the value of m is equal to 4. So the equation of the line would be that y is equal to 4x minus 14. And there you go. So that concludes again the examples on how to write the equation of a line in slope-intercept form when you're provided a slope and a y-intercept, when you're provided a slope and a point, like in this example, and like in example number 4, where you're provided 2 points that make up the line. So this one requires, again, this is the one that requires against more steps than anything else, because you have to use two different formulas. The first is a slope formula, and then y equals mx plus b to identify the y-intercept. Well, I hope this was helpful, and again, thank you for watching, and hope you have a great day.